What's up, guys? Let's talk about ionic propulsion. Traditionally, spacecrafts are propelled in space with a fuel like hydrogen and an oxidizer like oxygen, creating a rush of hot gas, which is then squeezed into a nozzle and pushed out, propelling the spacecraft forward. But while chemical propulsion is able to accelerate the spacecraft forward, it's relatively inefficient, needing to carry up hundreds of thousands of gallons of fuel that ends up burning out in a relatively short amount of time. And unfortunately, there are no gas stations or petrol bunks in space. So recently, there's been a large development in electric propulsion systems, like the electrostatic ionic thruster. Essentially, it replaces the hot gas coming out of a chemical thruster with a rush of ions, and there are numerous ways to leverage this phenomenon. For example, gridded ion thrusters use, wait for it, grids. First, it starts in the ionization chamber, where a cathode produces electrons and a neutral fuel gets injected into the mix. The idea is to take electrons, or negatively charged particles, off of neutral atoms. Electron bombardment, for example, uses electrons to bombard neutral atoms, knocking off an outer electron. Taking away the electron takes away a negative charge component, making it an overall positively charged ion. This is what happens in the ionization chamber, and we end up with a soup of electrons and positively charged ions. Now we need to push them out of our thruster, and we can do this using a series of grids reliant on Coulombic force, which is quantified by the product of two charges over the distance between them. This is the same phenomenon we observe when we see magnets attracting and repelling one another. As they get closer, the distance between them decreases, and the magnitude of attraction increases. And the opposite as they get farther apart. Back to our thruster, as more propellant is being ionized, the pressure of the ion soup increases, and the ions begin migrating towards a series of grids. In its simplest form, the thruster has two grids, a screen grid and an accelerator grid. The screen grid is positively charged, and if you remember, our little ion is also positively charged. So as pressure pushes it into the grid, the distance between the ion and the grid decreases, so that the magnitude of Coulomb force increases, and since like charges repel, our ion really wants to get away from the screen grid, so it accelerates itself farther down the thruster. Here, it encounters the accelerator grid, which is negatively charged. Opposites attract, so our little ion is ecstatic to see this grid, and rushes toward it. And right through it? Wait, why did they hug or something? That's where the neutralizer comes in. It takes the electrons we just made and shoots them out the back, making the overall contents behind the spacecraft neutrally charged. Therefore, the ions are no longer attracted to the accelerator grid, and they instead continue moving out.